Afternoon, my name is Al-Hashimy and I'm an AP Chem student, and today I'll be talking about how do lithium-ion batteries work. Okay, so lithium-ion batteries have become a huge part of our mobile culture. They provide power to much of our technology that our society uses, and a world without the lithium-ion batteries wouldn't be a proper world. Mobile devices, laptops, car batteries, everything, they would look huge and heavy. And without lithium-ion batteries, we wouldn't have most of the electronic devices we have now. So first, what are the parts of a lithium-ion battery? And first, I'll talk about how a battery is made. A battery is made up of several individual cells that are connected to one another. Each cell contains three main parts: a positive electrode, which is called the cathode, a negative electrode, which is called an anode, and a liquid electrolyte, which is inside the battery itself. So what are they made of? Just like alkaline dry cell batteries, such as the ones used in clocks and TV remote controls, lithium-ion batteries provide power through the movement of ions. Lithium is an extremely reactive element in its elemental form. That's why lithium-ion batteries don't use elemental lithium. Instead, lithium-ion batteries typically contain a lithium metal oxide, such as lithium cobalt oxide, which is the abbreviation for it is LiCOO2. This supplies the lithium ions, and lithium metal oxides are used in the cathode, and lithium carbon compounds are used in the anode. These materials are used because they allow for a process called intercalation. Intercalation basically means that these molecules are basically able to insert something into them. Like you can insert something into the molecules. In this case, the electrodes are able to have lithium ions move easily in and out of their structure and battery. So, what is the chemistry involved in lithium-ion batteries? Inside the lithium-ion battery, oxidation, reduction, redox reactions take place basically, and reduction takes place at the cathode. So their cobalt oxide combines with lithium ions to form lithium cobalt oxide, which is LiCOO2, like I said. And the half reaction is COO2 plus Li plus an electron, which gives LiCOO2. And oxidation takes place at the anode. Therefore, the graphite intercalation compound LiC6 forms graphite C6 and lithium ions. And the half reaction for that is C6 plus Li plus an electron with LiC6 plus COO2, which gives a reversible reaction to C6 plus LiCOO2. So, how does recharging a lithium-ion battery works? When the lithium-ion battery in your mobile phone is powered up. Wait, hold on. Okay, sorry for that. When a lithium-ion battery in our phone is powered, positively charged lithium ions move from the negative anode, moving through the electrolyte to reach the positive electrode, which is the cathode. Therefore, they are deposited. Those ions are deposited, and and the electrons, on the other hand, move from the anode to the cathode. When you charge a lithium-ion battery, the exact opposite process happens. The lithium ions move back from the cathode to the anode. The electrons move from the anode to the cathode. So basically the opposite. As long as lithium ions are making the track from one electrode to another, there's a constant flow of electrons, which provides the energy to keep our device running. Since this cycle can be repeated hundreds of times, this type of battery, the lithium-ion battery, is rechargeable. Okay, are there any risks with using lithium-ion batteries? As we learned, lithium-ion is extremely lithium. The elemental form of lithium is extremely reactive. When manufacturers make lithium-ion batteries, they have to take certain precautions so that these batteries are safe to use. However, we may have heard of electronics such as laptops, cell phone batteries bursting into flames because of their batteries. But this rarely happens, to be honest. And while these batteries are pretty impressive, they do have their downsides, and the biggest complaint is that they wear out fairly quickly when you use them and when we not use them as well. A typical lithium-ion battery will last about 2 to 3 years before it has to be replaced, and this gets expensive, obviously, because the production and disposal of lithium-ion batteries also has a big impact on the environment. So the longer those batteries can last, the better. And these are my sources right here. I use these two websites. Thank you for listening, and this is the end.